Hello, Algebra 2. Today we'll be looking at the Edgenuity section 7.4 called Properties of Probability Distribution. We have three objectives for this. The first is to create probability distributions from a data set. The second is to identify properties of a probability distribution. And the third is to solve problems using probability distribution. So let's look at how we would solve a problem using probability distribution and how we would interpret a table, things like that. So imagine that you have what we call a fair spinner. That is, it's just a like a plate with an arrow with like an arrow that you can spin on it, and it hits one of four colors: yellow, red, green, or blue. Sort of like if you're playing Twister, right? This is almost a setup for playing Twister. And the chances, so all the possible outcomes, the set of possible outcomes for spinning it twice, and what might happen is you might get a red, then another red. You might get a blue and another blue. You might get a yellow and another yellow, a green and another green, a red and a blue, or maybe a blue then a red and a yellow, or maybe a yellow and then a red, and so on and so on. Okay? So let's say that what we're interested in is anything with a yellow outcome. And we've got over here what we call a frequency table. And all a frequency table does is tell you how often something happens, how frequent it happens. Okay? So what we're going to do is, if you look at all of this information here, all of the possibilities, the frequency table for yellow tells you how many times this particular thing happens. So how many times in the bigger data here is there a combination that doesn't include yellow at all, that has 0 yellows? Well, there are 9 combinations with 0 yellows. So that's how you read this, right? How many combinations with 1 yellow? 6 combinations with 1 yellow. How many combinations with 2 yellows? 1 combination with 2 yellows. Okay, so that is one way of creating a frequency table. There are other ways of creating frequency tables, especially with the frequency or probability part of it. But and we're going to look at a probability distribution table as opposed to a frequency table, and they vary just a tad, but they're very similar. Okay, so we've got this frequency table, and the question is, what is the probability of only 1 yellow in 2 spins? So we're interested in an occurrence of only 1 yellow. And to give an idea, that means red and yellow, or yellow and red, or blue and yellow, or yellow and blue, or yellow and green, or green and yellow. There's all 6 of them, right there. So, so there are 6 opportunities, 6 chances of 1 yellow happening. Okay? So 6 chances of 1 yellow. And then how many total things do we have? Well, you add up everything on the frequency side of the frequency table. And if you do like 9 and 1, that's 10. And then 6 is 16. And then you can reduce that by 2. You can divide both of these by 2. and you get 3 over 8, which you could then put into a calculator, get a decimal, and Edgenuity talks about getting decimals, so let's put it into a calculator. 3 divided by 8, which then is a decimal of 0.375, which you could also write as a percent, 37.5%. So any of these three answers is an acceptable answer to that question. I'll give you a moment to look at that, and then we will move on. All right, let's move on to the next question. So now we're going to talk about a probability distribution table, and the difference, the big difference between a probability distribution table and a frequency table is that instead of putting how many times it happens, you put the probability percentage or the probability decimal of it happening. If you're using percentages, they have to add up to 100. If you're using decimals, it has to add up to 1, right? So let's read our situation. We sell 100 tickets. We sell them for $10 each. That doesn't really come into it. But the awards do. We get one, we're going to sell 100 tickets, pull out one ticket, and that one ticket will win $100, okay? So the probability of $100 is one, that one right there, in 100 tickets. Which, if you do that as a decimal, it's 1 per 100, 1 per century, that is 1%. So it's 1%, which is a decimal. You move the decimal 2 places smaller, and so you get 0.01. So for a prize money of $100, the probability is 0.01. Good. Then let's talk about the probability of winning $50. That is, we're going to pick out 4 of them out of the 100, tickets. So that is 4 per century, 4 per 100, 4%. So this is 4%, which move the decimal 2 places smaller, and you get 0.04 as a probability for winning $50, 0.04. Okay. Then we're going to win, some people are going to win $30. And that's 10 of them. So the probability of winning $30 is that we're going to draw 10 tickets out of the 100, which is 10%, which move the decimal 2 places smaller, and that's 0.1, a probability of 0.1. All right. Well, and then the rest is going to be donated to our favorite charity, Arts Academy in the Woods. And so what is left? So the probability of not winning any money, the probability of winning 0 money, that is the amount that's the probability that you're just donating to the cause. Well, how many tickets are left? Well, we did 1 ticket for 100, 4 ticket for 50, 10 tickets for 30, right? So that leaves us, if you do 1 plus 4 is 5, 5 plus 10 is 15. So if I do 100 minus 15, I get 85 tickets left, right? So that's 85. 85 of the tickets purchased out of the 100 tickets, their money is all going to be donated, right? Well, not all of their money. We're going to take out little bits of it to help pay for all the other money, and that question doesn't really come up in this problem, but anyways. So the probability that you don't win any money is 85%. Move the decimal 2 places smaller, so that's 0.85. And there's our probability distribution table right there. I'll let you look at that for a moment. And we've got just one question left to talk about. So here's a probability distribution table. And we've got 2 questions. A, what is the probability of getting a 3? Okay? I don't know what we're doing here, but you could either get a 0, a 1, a 2, or a 3, or a 4. Or things could happen 0 times, 1 time, 2 times, 3 times, 4 times, however you want to think of it. So the probability of the 3 happening, the probability, usually we want to use a capital P for probability. The probability of the 3 happening is just matching up the 3 with its probability, 0.2, or if you wanted to look at that as a percentage, you'd move the decimal 2 places larger to look at percentages. So that would be 20%. So the probability of 3 is 20%. What is the mean? So if you were to kind of draw over this and think about, like, okay, 0.1 and then 0.2 is a little bigger, 0.4 is a little bigger, and then 0.2 and 0.1. You kind of get that sort of thing. And if you remember from a previous section, the shapes that look kind of like that have the mean in the middle. So that would put you in the middle of this data. So the mean probability would be 0.4 or 40%. All right, well, I hope this helps. Thank you so much for listening.